Is it starting?
Yeah.
Okay. Sit down.
Nah.
Sit down. Okay, that's good. Okay. So, hello, Mr. and I, right? Today we want to talk about
Why is the whiteboard so blue?
Okay, that's fine because I used these. Okay, tissues. So, do you understand what's the rational number and irrational?
Rational is
Can you give me a few examples?
Irrational.
Pi.
Irrational can't be like expressed as fractions.
That's right. So, irrational
Pi.
numbers can be expressed as p divided by q, where p and q are integers, and also the great common divisor of p and q is 1. Okay, so meaning that p and q are coprime. So rational numbers can be
Like pi.
divided by
Pi,
expressed by this.
E.
Okay, yeah,
It's like
Wait.
phi.
Yeah.
It's phi and
like 1. You know,
It's phi. It's
One.
phi is a rational number.
or 5.
Phi.
The golden ratio.
Yeah.
Golden ratio, good point. Yeah, golden ratio. How did
It's
something like
circle
that,
and a
yeah.
line.
Yeah. Okay.
Yeah.
So rational numbers can be expressed by
I,
these,
yeah,
right?
not
Okay,
I.
wait. And then rational numbers either terminates or repeating. Okay, so terminates, right? 1,
Square root of
1.5, square root of 2 is here. So 1, 1.5, these are terminates. And 1/3, this is non-terminating. So which is 0.33, keep going, right? And we put the a dot above the 3, meaning that the digit 3 will repeat, okay?
Recurring digits.
Irrational numbers are non-terminating and non-repeating. Okay, so with the pi, there is no repeating, so the digit never repeats itself. So basically, in theory, you can find all combinations of the pi. Okay, 3.1. Yeah.
I'm just thinking that. Well, you know how irrational can't be like expressed as fractions.
Yes.
Like, can't you just be like pi over 1?
Then pi over 1.
Yeah, that's a fraction.
Pi over 1 is pi.
I
Yeah.
know, but that's a fraction.
But yeah, but the p and q, p over q, p and q are integers here.
Yeah, and pi is an integer with some decimal points.
Yeah. Okay. We get that, right? So today, we want to prove that y square root of 2 is irrational. Okay, square root of 2 is equal to 1.41 something, right? It never
5,
repeats.
6, 7, 8, 9, 10.
Okay. And then we talk
I mean,
about
it is
different ways to
it is
estimate the value,
repeating.
right?
I
Yeah.
mean, it is repeating each
No.
single digit, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
How do we estimate the square root of 2, by the way? Right?
We just take the first
Right.
few digits, not really.
Square root of 2 is bigger than 1 and smaller than square root of 4, which is 2, right? Yeah? So we say it's 1.1 plus x. X is the fraction, right? It's 1 point something. And then we do the square equals square root of 2. Okay? And then you know this, right? 1 square, right? A plus b square equals a square plus b square plus 2ab, right? 1 square plus s square plus 2x equals 2, right? Actually, plus equals this is square root of 2 square, right? Yeah? Okay, so this is 2. Okay, then we solve the equation. But this one, because this is a fraction, is too small. So we just append it, for now. Okay, so 2x equals 1, x equals 0.5. Right? So the first iteration, we got the estimation that the fraction is 0.5. So 1.5. But apparently this is not the answer, right? 1.5 squared is 2.25, right? We can keep repeating this process until we get a good estimation, right? Do you get my point? So okay, now let's come back to this. Y square root of 2 is a irrational number. By definition, right? Let's just assume, okay? We can use this, in mathematics, we can use this contradiction proof. Okay, so, by definition, right? If it's a rational number, let's assume it's a rational number.
1.5.
It can be expressed as p divided by q, where p and q are integers, right? Integers.
So
And also,
does that mean P and Q have to be the same? Or something?
no. Also, GCD p and q is 1. Okay. Yeah. Let's assume that. Okay.
The greatest common divisor of P
Yeah.
and Q.
So p divided by q equals square root of 2. Let's square on both sides. Okay. Yeah. From this to this. Yeah.
Yeah.
And then with p square divided by q square equals 2. And then let's move the q square to the other side because q cannot be 0, okay? So p square equals 2q square. Okay. So can you tell me from this one, p square equals 2 times q square. Is p square a even number or odd number?
Yeah.
Come on, 2 times something.
Even?
Yeah, this is even number. So p square is even. Okay, can you tell me p is even or odd number?
Even.
Yeah, because all times all cannot be even, right? Eric, does it make sense? So p is even, okay? Okay, if p is even, let's say p equals 2 times k. Okay, k is integer, okay? Yeah, because p is even, I can do this. Let's do this, plug this back. So 2k square equals 2q square. 4k square equals 2q square. Okay, get rid of these two. Okay. 2k square, k is an integer, right? Equals q square.
So can you just get rid?
So q is,
Q is k times 2.
yeah, q is even or? Even. The same thing, right? And then q square is even, right? And then q is even, right? So both p and q are even. So they must have a common factor of 2. Does it make sense?
Yeah.
But we just assume p and q, the greatest common divisor is 1. So they don't have a common factor of 2. So that's a contradiction. So the only possibility is that this square root 2 cannot be represented by p over q. Okay, because it contradicts. Does it make sense?
Why does P and Q need to be the simplest form? Why can't it just be like 2 over 4 or something?
Oh, 2 over 4. 2 over 4 will be, that's a very good question. It will become 1 over 2. Okay?
Yeah, but why does it need to be like the simplest form?
Because we make an assumption. That's our assumption. Yeah, we made the assumption. And then it contradicts the assumption. So it means that our assumption at the beginning is wrong.
Yeah, I know why you're proving. I know how you're proving it. I know how you're proving it, but I just don't see like why does it have to be like the simplest form? Why can't it just be 2 over 4?
Then we can't prove this way. But
I know,
Okay.
but like why does it have to be 1 over 2? Rather
because any fractions can be represented by using the simplest p over q. Anything.
yeah, but with P and Q aren't. With P is 2 and Q is 4.
Then it's actually the same as p is 1, q is 2.
Yeah, but P.
Prime.
Yeah, but P is even and Q. Yeah, but P is even and Q is even, so that just works.
Okay, I don't know how to convince you, but what I'm saying is that we make the assumption in the beginning. Can I make the assumption, right? Because of p and q, the greatest common divisor is 1, right? That's the definition of the rational number.
Yeah, so
Any number.
yeah, so 2 over 4 isn't rational. Because 2 over 4 is rational, that means if P equals 2 and Q equals 4, then couldn't that just be rational? Like, it's rational, right? So can't you just use it?
No, but yeah, but I understand. But the thing is that we made the assumption p and q common factor over them is 1. Is the coprime. This is the definition of rational.
Yeah, so 2 over 4 isn't rational.
Yeah, it's the 2 and 4 we can divide by the common factor, which is the
So is
2.
2 over 4 not rational?
It's rational, yes.
Yeah, so why can't we use it?
Yeah, you can use it, but when you use it, you can't prove this. But now we just made the assumption p and q are simply in the simplest form, so we can prove if there's a contradiction. That's the thing. Okay.
If square root of 2 was rational, if square root of 2 was rational,
Yeah.
can't you just multiply both sides by like 2 to get like 2 over 4 or something? And then it'll work fine.
I'm not following you. Please.
If a square root of 2
Yeah.
was rational,
Yes.
you could just multiply the numerator and the denominator by 2, and then it'll just work like for those
By
people.
2.
Yeah, like just use your imagination. If that's square root of 2, then can't you just multiply both sides by 2, and then you get this will work fine.
Okay, yes, but the thing is that we made the assumption and then we prove it's a contradiction. So it means that our assumption is wrong. That's the key thing, right? Of course, you can make an assumption, but that doesn't work. Okay.
Yeah, but all we know that is that both, if it was like, if square root of 2 was rational, then both sides would be like even, and you can do that.
Yes, you can do that, but that's going nowhere, right? Because
No, it is because you can make square root of 2 like follow all those rules.
Okay, the problem is that the rational number, when we define the rational number, any
Yeah.
rational number can be expressed by P over Q, where
Yeah.
P and Q, this is the definition. This is the definition, okay? You're proving that not from the definition. That doesn't work, okay? That is not right.
Yeah, I see, but so does that mean 2 over 4 isn't rational?
2 over is rational because it can be simplified over this, to this. This is this. Any number can be expressed by this. This is a rational because it can be expressed by that. Okay?
Yeah.
What about 3's too? What about 3 halves?
3 half.
Yeah.
3 halves. 3.
1.5.
1.5.
Yeah, you can't simplify that.
Because 2 and 3 are co-prime. The greatest common divisor between these are 1, and both these are integers.
Is it because if it's not a prime number, you could just divide by it?
Okay.
How about like 9 halves?
9 halves is 9.1. 9.5.
No, 9 halves is like 4.
4.
No, 4.5, I think.
4.5. Then it's 9 divided by 2. 2 and 9. The greatest common divisor is 1.
Oh.
Co-prime. Okay. Okay. I can have this discussion after. Okay.
Yeah.
What
so
about
you need
100
to-
over 1? 100 over 1.
101.
100 over 5, let's say.
Yeah, but
That-
like, can't you just explain? Like, for 2 over 4, you're saying it's rational because you can convert it into 1 over 2.
Yes.
Yeah, and 1 over 2 is rational. But, so you're basically saying 2 over 4 doesn't really work, so we just change it to 1 over 2 and now it's
No. 2 is rational.
Yeah, I know. But what you're saying is that P and Q has to have a greatest common divisor of 1.
Yes.
But 2 and 4 doesn't, so...
2 and 4 greatest.
Can be any rational can be converted into P over Q. Okay? Because these can
Yeah,
be
but
converted
what
to,
if square root of 2 is like 2 over 4?
then it's like that, and it can be converted to this.
Yeah, so
You know?
that means square root of 2 can be converted into 1 over 2, and while also following those rules at the bottom.
You don't know what's greatest common divisor? It's
Yes,
the
I
same
do.
thing. It's the same thing. Like 15 and 12. What's the greatest common divisor?
I know,
What's
3.
3, yes, because this can be expressed by 3 times 5, and this could be expressed by 3 times 4. And then we get rid of the
Times 3, the same parts. We get rid of the same parts.
yeah, we get rid of the same
We
part.
need
So
to
that's
do-
5 portion, that's 4 portion. Okay, so how do we get the 5 portion and 4 portion? How do we do
You
it?
just need to like,
Yeah, how do we
Right,
get the
but-
greatest common divisor of this?
you need
15.
to do like, you could do prime factorization.
Yes. But how do we get this 15 and yeah? One way, easy way. We always subtract the biggest number.
Yeah, I know,
from,
I
yeah.
know, I
So
know. And then
15
because-
minus 12
Yeah,
is,
I know,
is 3.
I know.
And then 12 minus 3, 9. Right? Yeah? 9 and then 3 minus 3, 6. 6 minus 3, 3. Okay? 3 and 3 equal. So this is the. So we can
I know,
always get the greatest common divisor. If it's it's 2 over 4, we can do this until we can repeat this process. Then we get the greatest
Yeah,
common
but why
divisor.
do you need to? If it's already rational.
No, it's rational, but how do we know it's rational? We need to convert it to this form to make sure that it's rational. Okay? Okay, so since we're here, right?
Yeah.
We can repeat this process. If we can't repeat this process,
Okay, my point is that.
yeah. Your point is what?
My point is that because you're saying P and Q, if it were to be square root of 2, then I'm just thinking like you're saying that both P and Q have to be even, and then I'm just thinking that it could be square root of 2 could just be like 2 over 4, and 2 over 4 is rational, and both P and Q are even. So I'm saying square root of 2 could be just like 2 over 4.
Yes.
And
But
two
if you don't limit that, then you can't prove. Okay, you can't prove.
I know.
Mathematics, you can't.
Okay, for the like second time,
Yeah.
or maybe like I don't know 20th time.
Okay.
Like, I'm just saying, what if square root of 2 is like 2 over 4, where the greatest common divisor isn't 1? Because 2 over 4 is rational.
Yes.
That means square root of 2, if it were to be, because P and Q, I know square root of 2 isn't rational, but basing on your proof, like, I'm just saying that it could just be like rational because 2
It could. You say it could.
Yeah,
But mathematically,
I know, but I know it isn't rational, but this proof isn't, if I didn't even know square root of 2 is irrational.
it could. Could is not a proof.
I know. I'm not proving.
Yeah, okay. Yeah,
Okay.
you make a point. Yeah, I understand
You're
now.
not even.
Yeah, I do understand what you
No, you
said.
don't.
You said if square root of 2 is like 2 over 4,
Yeah,
and then this could work, right?
yeah.
But that's the possibility. You're
Yeah.
not proving it.
Yeah, but 2 and 4 is even.
I know, but you're not proving it. You're proving nothing. You make the assumption,
Yeah.
and then you get what you want.
Yeah, I'm not proving.
Yeah,
I'm just trying to like get around your proof
I see.
because it doesn't really work.
Yeah, you say it doesn't work, right? It doesn't work.
Yeah, in my view, like because you're saying P and Q has to be even, and that means that it isn't rational.
Yes. So, okay, I said,
Uh,
okay, let me repeat your point, okay? You said square root of 2 could be 2 over 4. Okay, and then we do this calculation. Yes, we got that. P
Yeah.
and Q could be even. Yes. Okay, what do you get from that?
2 and 4 is rational, so that means square root of 2 is because it's basically like that. That means you can simplify it so that is also has a greatest common divisor of 1. So that means
No, that proof is wrong because you said you make an assumption and then you get what you want. This is not proving. You say okay, 1 plus 1 equals 3.
Yeah, but-
Then you say okay, let's multiply it by 2. Then 2 times, then I can prove 2 times 2 equals 6. This is exactly what you mean. You said this and then you get that. So what can you get? This is not proof.
how's it like that?
Because you're saying that P and Q is square root of 2 is rational, and then you get based on your wrong assumption, you get what you want, which is
What does it have to do with 1 plus 1?
and this is example. Okay, this is example.
1 plus 1 isn't 3 though.
I know 1 plus 1 equals 3 because you're saying square root of 2 is 2 over 4. It's kind of like 2 over 4. It's not. This is false. This is false. You got this. You get
I'm not saying square root of 2 is exactly like 2 over 4.
yeah.
I'm just saying that P and Q both could be even.
Yes, could be even, but P and Q could be even. Then if it can be even, then it could be we could have a 2 factor. We could factor out. Then P and Q.
Yeah, but why don't we?
This is a definition. That's definition.
Yeah, I know.
We coming back again. Okay, I'm going to discuss it with you because this is going to take a long time, and it's quite interesting. I want to have a long discussion with you later. Okay, but let's go back to this. Okay, because otherwise it's going to take forever. 12 and 15. Well, we can do this subtraction until we get in the same part. Then we know actually the ratio. Okay, let's prove this using mathematics, using geometry. Okay, geometry. This is the last bit of the video today. Okay, the triangle, right? You know that, right?
Mm-hmm.
This is the right triangle. If this is 1, this is 1, this is
1.
square root of 2, right?
Yeah.
Because a square plus b square equals c square. A, b, this is right triangle. This is called, what do we call it?
Pythagoras theorem.
Yeah, okay.
Pythagorean.
Okay, so what do you call this kind of triangle? This side equal that side.
Right angle isosceles.
Okay, good. So look, this is square root of 2. This is 1, right? We say this. Okay, so we want to compute square root over 1. If it's a rational number, I want to do this side over this side, right? Square root of 2 equals the longer side ratio to this one, okay? How do we do it? Remember, 15 and 12. We use the shorter side to subtract from the bigger side, okay? How about if I do a bisector of the angle? Okay, this angle equal that angle, okay? And then I do a, what do you call it? I do a perpendicular line.
Perpendicular.
Perpendicular, okay? So what's the relation between these two triangles? What's this angle equals this angle?
They're like congruent.
Congruent is the same, right?
Yeah,
Identical.
yeah.
Okay,
Yeah.
identical. Okay.
Yeah.
So these two angles is the same. So this side equals this side. This side equals this side. Okay. Yeah. So the longer side, we want to subtract the shorter side from the longer side, right? So this side, okay, let's label it A, B, C, D, E. Okay. AC minus AB, right? We want to say AC minus AB. AC, AB. AB can be moved to here, right? Because these two triangles are the same. So AC minus AE is this side, right? CE, okay?
Yeah.
Now CE, shorter side. Subtract CE from AB, right? Yeah? So AB subtract CE. CE, okay? Look, this is right angle. This is 45 degree, right? This side equals that, right? Yes? CE equals ED, right? ED equals BD, right? So this side equals that side, right? CE equals DE. DE equals BD. And then AB minus CE. AB is this side. AB equals
Wait,
BC.
how do you know DE and EC are the same on this part?
45 degree.
Alright, yeah.
This is 45 degree.
Yeah.
So this side equals that side equals that side, okay? So AB minus CE equals BC minus BD. Okay? BC minus BD equals BC. Okay? So now we have a new set of things. CE and DC. CD and CE, okay? So this side and then that. Originally we want to, this is the longer side, this. And then now I got this and this. What do you notice that? What do you notice the thing? This triangle, rotate it.
Yeah.
CE will be this one. CD will be this one.
I know, but also, can I write something?
Yeah. So what does it mean?
EC, no, I actually don't need a pen, I just wanted to point.
Yeah.
So, EC must be square root of 2 subtract 1.
C will be square root of 2 subtract 1. What's 1? Yes. You're right. Yes. Yeah, but the value is not important. We want to repeat this process until we, but we can't because look, we got another triangle which is smaller, but the shape is exactly the same, and we can repeat this process, continuously forever.
I don't get how is that proving that it's irrational.
So if by doing that, look, 15 divided by 12, we can prove it's rational because we eventually will turn into, we can get into
So how
5 over 4, right?
if if square root of 2 was rational, how would the triangle act like?
Then it will end. This process will end at the final step. Then we can get a value like that. But the thing is that we cannot because we can repeat this process. It's the same. You can keep doing this. You can keep doing this by doing that, right? You can keep doing that. You won't lead you to list P and Q, where common divisor is 1 within the final step. So we can't using this approach to get a value. So it means that square root of 2 is irrational.
Okay, also, why do you split it like that?
Swear?
Why do you split it like that?
Which part?
Split it.
Why do you split it like that?
Because we want to prove. Okay, but do you get my point? Yeah. Do you get my point? We want to subtract this from that, and then it turns out we get this and this, and this is exactly the same but smaller triangle, but exactly the same, right? It's the right triangle with 45 degree. Okay, I don't know how to call it. Right triangle, same side. Okay, you just got a smaller part. Okay, so summarize. We got 2 ways to prove that square root 2 is irrational. Okay, any question for today? Good discussion. I'm going to discuss this with you. Okay, I know your point, but it's really hard to convince you somewhere. Okay, good job today. Bye bye.
Bye.